Most machines are built to work on the ground. These machines are built to change it. They cut roads into mountains, tear through rock, move hundreds of tons at a time, and keep working in places where an ordinary machine simply wouldn't survive. And size isn't the whole story. Some of the machines you're about to see aren't here because they're the biggest. They're here because each one solves a problem that almost nothing else can. A dozer has to find traction where the ground fights back. A loader has to keep trucks moving without wasting a cycle. And farther into the mine, hydraulic excavators take on loads so large that a single bucket can change the rhythm of an entire haul fleet. But eventually, even that isn't enough. Because at the far end of this journey is a machine that doesn't really drive across the mine. It walks and moves earth from nearly a football field away. So how extreme does a mine have to become before ordinary heavy equipment is no longer enough? We're about to find out. In the mountains of France, mining doesn't begin with a giant excavator. It begins by creating ground strong and stable enough for everything else to work on. That's the job of the Caterpillar D10R. Weighing more than 140,000 pounds and powered by a Cat 3412E producing around 570 horsepower, the D10R uses its large blade to cut, push, and shape loose earth and rock across steep terrain. Behind it, a heavy ripper can break into compacted ground and weathered rock that lighter machines may struggle to handle. On flat ground, a dozer can look like a support machine. In the mountains, it can decide where a haul road goes, where heavier equipment can safely stand, and which areas of the site remain accessible at all. Every pass of the blade does more than move material. It creates the working surface the rest of the mine depends on. And in steep, narrow, rocky terrain, that is exactly why a machine like the D10R exists, to keep working where lighter equipment can no longer do the job safely or effectively. If the D10R creates the ground a mine can work on, the Komatsu D475-8 takes that job to a much larger scale. This is a dozer built for jobs where the volume and resistance of the material have moved into another class. At more than 250,000 pounds, the D475A can put enormous traction through its tracks and sustain heavy pushes across large working areas. Powered by a Komatsu diesel producing 890 horsepower in forward travel, it has the strength to move huge amounts of hard, loosened material, reshape benches, clear working areas, and prepare ground for the equipment that follows. Its blade can carry roughly 36 to 45 cubic yards in standard mining configurations. And when the ground becomes harder, the ripper at the rear adds another layer of capability. The operator lowers the tooth into fractured or weathered material, then uses the machine's weight and traction to pull it through the ground. The goal isn't to crush solid rock by force alone, it's to exploit natural weaknesses, loosen the surface, and make the next pushing cycle faster and more efficient. That distinction matters, because even a dozer this powerful has limits. Hard, unfractured rock may still require drilling and blasting. But where the geology allows mechanical ripping, the D475A-8 can reduce the preparation needed before the material is moved. And that's where its real value becomes clear. The D475A isn't just a bigger version of the machine before it. It's built to keep large sections of a mine moving when the amount of material, the resistance under the tracks, and the production target have all become much greater. The Caterpillar 992K may not look as extreme as the dozers we've just seen, But in a quarry, its challenge is completely different. It has to move quickly, hit the pile hard, lift heavy broken rock, and repeat the same cycle hundreds of times without slowing production. Powered by around 814 horsepower and weighing more than 230,000 pounds, the 992K carries buckets in the 14 to 16 cubic yard range. In limestone operations, that gives it enough capacity to load large Cat 777 haul trucks in a small number of passes. Watch how it works. The loader drives straight into the pile, fills the bucket under heavy resistance, reverses, pivots through its articulated frame, then raises the load high over the truck body. Everything happens fast because every extra second adds up over an entire shift. And that's what makes the 992K valuable. It combines the mobility of a wheel loader with the strength needed to handle dense rock again and again. In a high-production quarry, that balance can matter more than sheer size, because this machine isn't built to dominate the mine. It's built to keep up with it. At an iron ore operation in India, the Komatsu WA900 starts its shift where the material is heavy, abrasive, and constantly moving. Its job is straightforward in principle. Get into the pile, fill the bucket, and keep the loading area moving. But doing that all day with dense ore is anything but easy. Weighing more than 256,000 pounds, the WA900 is one of Komatsu's largest wheel loaders. Its 12-cylinder diesel produces about 899 horsepower, while bucket options range from roughly 15 to 19 cubic yards, depending on the material and application. From the cab, the cycle happens fast. The loader drives into the pile, fills the bucket, reverses, turns through its articulated frame, then lifts the load over the side of a waiting haul truck. With iron ore or broken quarry rock, every pass sends heavy loads through the tires, axles, transmission, hydraulics, and bucket structure. What makes the WA900 different from a large tracked excavator is mobility. It can leave one loading point, cross the working area, attack another pile, and begin loading again without needing to be repositioned by support equipment. That flexibility is especially useful in mines and quarries, where stockpiles, loading points, and production priorities keep changing. Komatsu designed the WA900-8 to work with haul trucks in roughly the 70 to 150 short-ton class. So despite weighing more than 128 short tons itself, the machine can still move around the site quickly enough to follow the work, instead of waiting for the work to come to it. For a machine this large, that combination of loading power and mobility is what makes the WA900 so useful in demanding quarry and iron ore operations. Long before today's newest ultra-class excavators arrived, the Terex O&K RH340B was already doing work on a scale few hydraulic machines could match. Built for large open-pit mines, it was designed to dig through heavy overburden and waste material, then load haul trucks carrying hundreds of short tons. In face shovel configuration, the RH340B weighs about 625 short tons. Its twin-engine power system produces around 3,000 horsepower, while the standard shovel bucket holds roughly 44.5 cubic yards. At the digging face, the machine pushes the bucket directly into the broken material. The crowd system drives the teeth forward. The hydraulics lift the loaded bucket, and the upper structure swings toward the waiting truck before the bottom of the bucket opens and releases the load. A full bucket can carry roughly 67 short tons of material under the rated conditions used in Bucyrus documentation. That was enough for the RH340B to load a 205 short-ton class mining truck in about 3 passes, or a 240 short-ton truck in roughly 4. What made the RH340B important wasn't just its size. It showed how far hydraulic excavation could be pushed before today's newest machines appeared, combining huge digging forces, precise hydraulic control, and the ability to load ultra-heavy trucks cycle after cycle. Even today, footage of an RH340B at work still looks extreme, and that says a lot about how far ahead of its time this machine really was. In some open-pit mines, the challenge isn't just digging. It's handling enormous volumes of earth and waste material shift after shift without letting the operation slow down. That is exactly the kind of work the Liebherr R900-8 and Euclid Hitachi EH4500 were built for. The R900-8 itself weighs nearly 1.5 million pounds, with 3,000 horsepower and a shovel holding about 44.5 cubic yards. Those numbers are close to what we've already seen from the RH340B. Beside the excavator is the Euclid Hitachi EH4500. Depending on the version, it can carry more than 250 short tons of material in a single load. Once full, the truck has to move that weight over mine roads covered in dust, loose material, steep grades, and constant vibration. Conditions that would quickly overwhelm ordinary road-going vehicles. The contrast between the two machines is striking. The R900-8 stays close to the working face, repeatedly digging and loading material. The EH4500 takes each load away across the mine, carrying hundreds of thousands of pounds at a time. This is what extreme mining equipment is really about. Not simply building a larger machine, but creating equipment that can keep handling extraordinary loads in places where ordinary machines would quickly reach their limits. The Komatsu PC7000 enters a different level of hydraulic mining. Built for large open-pit operations, it has to dig, lift, and control huge loads while working beside haul trucks that can carry hundreds of short tons. The PC7000 weighs roughly 747 to 771 short tons, depending on configuration. 2 Komatsu engines produce a combined 3,350 horsepower, while the standard bucket holds about 50 cubic yards. But what stands out isn't just the size. When the bucket enters heavy material, thousands of pounds of hydraulic force are being transferred through the boom, stick, bucket, and front structure at the same time. Then the entire upper body swings with the load before placing it into a waiting truck. Komatsu designed the P7000-11 to work with mining trucks in roughly the 240 to 290 short-ton class. That means only a few bucket passes can put hundreds of tons of material on the road. And despite weighing well over 700 short tons, every movement still has to be controlled with precision. Too much shock, poor positioning, or an uneven load doesn't just waste time. It puts enormous stress through a machine expected to repeat the same demanding cycle for thousands of hours. But there are mining jobs where even an excavator this powerful is no longer the right answer. When the area to be stripped becomes wider, deeper, and far beyond the reach of a conventional hydraulic machine, engineers turn to something completely different. At the Sasan coal mine in India, the Caterpillar 8200 works on a scale that changes the way you think about excavation. It doesn't rely on hydraulic cylinders, and it doesn't need to sit right beside the material. Instead, it uses cables, a 328-foot boom, and a bucket that can hold roughly 60 to 80 cubic yards. The 8200 is an electric walking dragline, weighing roughly 8.4 to 9 million pounds depending on configuration. Its job is to remove enormous volumes of overburden and expose the coal seams below. Work that would require an entire fleet of smaller machines to match. These machines weren't built just to be bigger. They were built because some mining jobs leave no room for ordinary solutions. Different machines, different limits. One purpose: to keep large mining operations moving where ordinary equipment reaches its limits. So where do you think the real limit is? More size, more power, or a completely different way of working? Tell us in the comments. And if you enjoy seeing the machines behind the world's toughest mining operations, subscribe to Beast Machines World for more.